Hi, this is Jayaraj. Let's implement gradient descent in a simple setting. If you are given a bunch of data points like this, we want to fit a line like this so that if you are given an x later on, we want to predict the corresponding value y. So how gradient descent works is, we start with some random line, let's say like this, and then we look at the error between the predicted values lying on this line and the actual values, and we change the line such that this error is reduced a little bit. So we may adjust the line like this. The line is parameterized with a single parameter m and has the form y equal to mx. So we make a change to m such that the error reduces a little bit during each iteration. So we may keep changing m like this so that we keep moving towards optimal value of m. If we change the value of m too much, then from here we may go over to the other side. So we may have a much larger value of m, and then we may keep going back and forth. Whereas if we keep changing the value of m by a small margin, then it may take a long time to get to the optimal value, and the margin by which we keep updating the value of m is called the learning rate in machine learning. So how do we know how to change the value of m such that the error is minimized, error reduces at each step? So if we look at the error function, that is, if we plot the mean square error between the predicted and actual values versus m, in this particular case we will get a curve like this, and on the right hand side, if the value of m is too large, then we see that the slope of the curve is positive. That is, if we make a small change to m, the error increases. On the left hand side, slope of the curve is negative. That is, if we make a small change to m, the error decreases. So since we want to keep decreasing the value of the error, we just need to keep moving in the opposite direction of this rate of change of the error, which is nothing but the derivative of the gradient. And that's why it's called the gradient descent. So now let's look at how to implement this simple concept in Python. So this is a typical, this function has a typical signature of a machine learning, a training function. So it takes the x values to a list of x values and list of corresponding y values, and another pair of x and y values called the validate set, number of iterations, learning rate, and as in this particular case it also takes a starting value from, we can start with some random value. So here you can see that, so we are repeating this process for n iterations, and here you can see that we are computing for each point in the training set, we are computing the error of the predicted value against the actual value. So this is the error. So predicted value is x into m and y minus, so we are taking the square of the difference. And then we are making a small delta change to m. dm is a very small value, and we are looking at the error at when m is m plus delta m. And then here we are looking at this the ratio, the difference between the mean square error of at the point m plus delta m and m divided by delta m, and this is nothing but the derivative. So in a kind of a brute force manner, we have looked at the derivative, and then we change the m such that since we must go in the opposite direction of the gradient, we multiply the gradient or the derivative with what is known as the learning rate, and then subtract m subtract that from m. So we keep changing the value of m such that m decreases in the opposite direction, or m changes in the opposite direction of the gradient. And then we look at the error in the validate set, and then we track the value of m, which gives us the lowest error in the when looked at against the validate set. So this is a very raw implementation. This is not how it's usually done, but this shows the basic concept. But here the problem is that we are actually calculating this error function twice, and this calculation, calculating the y predict value, may be a complex operation with a lot of parameters. So this is going to be computationally expensive. So we can actually use the properties of derivatives. So if you want to look at, if you want to take the derivative of y predict minus y the whole square with respect to m, then we can just do a derivative analytically, and then we will get this symbolic expression 2 into y predict minus y multiplied by x. This is the derivative of this function at any point m. So that's what we are actually doing here. So we look at the derivative of the error function with respect to m, and then so instead of calculating the error function twice, we directly look at the derivative. So we can use the properties of derivative to reduce the duplicate computations, and that's how machine learning frameworks work. And they use more advanced ideas like automatic differentiation. And then we change the m in the opposite direction of the derivative. So this is an alternate implementation using the properties of derivatives. And this is the main module. And here you can see this is the flow of a typical machine learning a training module. So we first read the training data, and then we take x and y values. Then we split into training and validate set, and then we pass it to the training function, and then we just give the training statistics. So so let's just run it once and see. Just a minute, it takes a little bit time to load the data. Yeah, so you can see that, so this is how the value of m has, so we started with some large value of m, random value, and then m kept decreasing, and this is the final value, which is where the error is close to 0. This is the error on y-axis, and so this is how it has progressed. And then you can see that the best m is, this is the value of m with error 0.02% in training time is this. So this is a very simple implementation of gradient descent, and this basic idea is used in a lot of different machine learning approaches, and this is a workhorse. Gradient descent is today's workhorse in machine learning. Thank you.